So in this lecture we will be discussing about carbon and its form in nanomaterial, that is mainly graphene, nanotubes, carbon nanotubes, and buckyballs. These are the 6 main types of nanoforms of carbon available. We will take up one by one. Now, you might have all learned previously in your school and university college days that carbon uh, has got different forms of allotropes. And the most stable one of all the allotropes is graphite. Graphite is the material that you will find in your pencil leads. You will find graphite at the tip. Now, if you look at the structure of graphite, so it actually forms as multi-layers of carbon monolayers. So you have monolayers of carbon stacked one upon each other, and they are joined by van der Waals forces. So this multi-layered stacking of sheets of carbon that makes what is known as graphite. Now somehow if you could remove some sheets of it, that means either 1 to 5 atomic layers or monolayers of carbon, if you can separate it out from the bulk, then these layers show different properties. These layers show properties which is different from the whole bulk, and they are popularly known as graphene. Single or up to 5 layers of carbon monolayers you will have. You can call it as graphene. More than 5, sometimes the bulk properties that gets dominant. So we would keep it to 1 to 5 monolayers. If you take one of the layers of carbon, one of the atomic layers of carbon, so it is has got a shape like this. So we have hexagons, another hexagon, so there are 6 carbon atoms, 1, 2, 3, 4, 5, 6. So you have a stack of hexagons, and so let's write it as hexagons. And if you could roll it, if you roll the hexagon, so we get what is popularly known as carbon nanotube. Now these nanotubes will be again, the properties of the nanotube will depend how are we rolling it. So there is a mathematical term called chiral or wrapping vector. And it is denoted by a quantity called C. So C is written as equal to N into A1 plus M into A2. And what are these A1 and A2? A1 and A2 are the basis vectors that means if we take one of the carbons, say here, as the origin, then this one is your A1 and this one here is your A2. N and M are integers. Now, as I told you, how we are wrapping it will depend upon these N and M quantities. We can wrap it along this direction. We can wrap it around this direction, or we can wrap it along any one of the directions of A1 and A2. So if we wrap it along this direction, then N will be equal to M. And if we wrap it along this direction, then there will be only one N. There will be no M. So N is 0. So that means either we can have N equal to M, or we can call it NN wrapping, and we can have N0 wrapping. So this NN wrapping, this is called an armchair carbon nanotube. Whereas this N0 wrapping is called a zigzag carbon nanotubes. And why it is called an armchair carbon nanotube? If you look closely again to the structure, if we are rolling it in this direction, NN direction, so the shape after you roll it will look something like this. So you have a carbon nanotube, so you have rolled it and you have got a nanotube here. So the shape will look something like this. It forms the shape of an armchair. So this is NN. Whereas the other one, it actually looks something like this. Okay, so this becomes a N0 or zigzag. Anything in between N and M, we just call it a chiral wrapping, where there is no particular relationship between N and M. Anything in between these two. So basically we have an armchair, we have a zigzag, and we have a in between these two that is called a chiral carbon nanotube. Now this is about graphene. Apart from graphene and carbon nanotube, we have another allotrope of carbon which also shows nano material properties, that is called a C60 molecule, or it's also called fullerene. Basically it is like a shape of a football with nanotube or carbon atomic layers on the surface. So there are basically 60 atoms, carbon atoms, surrounding the whole structure. That is why the name is 60. This is in fact the first molecule to be called as nano. First molecule to be called as nano. Okay.